التوتال كواليتي مانجمنت shortly TQM. A primary role of management is to lead an organization in its daily operation and to maintain it as a viable entity into the future. Quality has become an important factor in both of these objectives. The term total quality management refers to a quest for quality in an organization, and there are three key philosophies in this approach. One is a never-ending push to improve, which is referred to as continuous improvement. The second is the involvement of everyone in the organization. And the third is a goal of customer satisfaction, which means meeting or exceeding the customer expectations. Also, a TQM expands the traditional view of quality, which is looking only at the quality of the final product or services, to looking at the quality of every aspect of the process that produces the product or service. TQM systems are intended to prevent poor quality from occurring. We can describe the TQM approach as follows. First, find out what customers want. This might involve the use of surveys, focus groups, interviews, or some other technique that integrate the customer's voice in the decision-making process. Be sure to include the internal customer as well as the external customer. Second, design a product or service that will meet or exceed what customers want. Make it easy to use and easy to produce. Third, design processes that facilitate doing the job right the first time. Determine where mistakes are likely to occur and try to prevent them. And when mistakes do occur, find out why so that they are less likely to occur again. Strive to make the process mistake-proof. This is sometimes referred to as a fail-safing, which means elements are incorporated in product or service design that make it virtually impossible for an employee or sometimes a customer to do something incorrectly. In other words, incorporating design elements that prevent incorrect procedures. Fourth, keep track of results and use them to guide improvement in the system. Never stop trying to improve. Fifth, extend these concepts throughout the supply chain. Sixth, top management must be involved and committed. Otherwise, TQM will just be another fad that fails and fades away. The preceding description provides a good idea of what TQM is all about, but it doesn't tell the whole story. A number of other elements of TQM are important, which are: first, continuous improvement, which can be defined as the philosophy that seeks to improve all factors related to the process of converting inputs into outputs on an ongoing basis. Also, it covers equipment and methods and materials and people. Second, competitive benchmarking. This involves identifying other organizations that are the best at something and studying how they do it to learn how to improve your operation. The company need not be in the same line of business. For example, Xerox Corporation used the mail order company LL Bean to benchmark order filling. Third, employee empowerment. Giving workers the responsibility for improvements and the authority to make changes to accomplish them provides strong motivation for employees. This puts decision-making into the hands of those who are closest to the job and have considerable insight into problems and solutions. Fourth, a team approach. The use of teams for problem solving and to achieve consensus takes advantage of group synergy, gets people involved, and promotes a spirit of cooperation and shared values among employees. Decisions based on facts rather than opinions. This is the fifth element, which entails management gathers and analyzes data as a basis for decision making. Sixth, knowledge of tools. Employees and managers are trained in the use of quality tools. Seventh, supplier quality. Suppliers must be included in quality assurance and quality improvement efforts so that their processes are capable of delivering quality parts and materials in a timely manner. Eighth, champion. A TQM champion's job is to promote the value and importance of TQM principles throughout the company. Ninth, quality at the source. Quality at the source refers to the philosophy of making each worker responsible for the quality of his or her work. Quality at source accomplishes a number of things. It places direct responsibility for quality on the person who directly affects it. It removes the adversarial relationship that often exists between quality control inspectors and production workers. And it motivates workers by giving them control over their work, as well as pride in it. 10th, suppliers are partners in the process, and long-term relationships are encouraged, of course, with suppliers. This gives suppliers a vital stake in providing quality goods and services. Suppliers also are expected to provide quality at the source, thereby reducing or eliminating the need to inspect deliveries from suppliers. Obstacles to implementing TQM. Companies have had varying success in implementing TQM. Some have been quite successful, but others have struggled. Part of the difficulty may be with the process by which it is implemented rather than with the principles of TQM. Among the factors cited in the literature are the following. First, a lack of a company-wide definition of quality. Efforts are not coordinated. People are working at cross purposes, addressing different issues, and using different measures of success. Second, a lack of a strategic plan for change. Without such a plan, the chance of success is lessened and the need to address strategic implications of change is ignored. Third, lack of customer focus. Without a customer focus, there is a risk of customer dissatisfaction. Fourth, poor intra-organizational communication. Fifth, lack of employee empowerment. Not empowering employees gives the impression of not trusting employees to fix problems. Sixth, view of quality as a quick fix. Quality needs to be a long-term and continuing effort. Seventh, emphasis on short-term financial results. Eighth, inordinate presence of internal politics and turf issues. This can sap the energy of an organization and derail the best of ideas. Ninth, lack of strong motivation. Managers need to make sure employees are motivated. 10th, lack of time to devote to quality initiatives. Don't add more work without adding additional resources. Finally, lack of leadership. Managers need to be leaders. This list of potential problems can serve as a guideline for organizations contemplating implementing TQM or as a checklist for those having trouble implementing it. Problem solving and process improvement. In this topic, we are going to discuss the basic steps of TQM problem solving process and the plan, do, study, act cycle. And finally, a Six Sigma approach. The basic steps of TQM problem solving process. Problem solving is one of the basic procedures of TQM. In order to be successful, problem solving efforts should follow a standard approach. Also, an important aspect of problem solving in the TQM approach is eliminating the cause so that the problem doesn't recur. This is why users of the TQM approach often like to think of problems as opportunities for improvement. Now, we are going to describe the basic steps in the TQM problem solving process. Step 1. Define the problem and establish an improvement goal. Give problem definition careful consideration and don't rush through this step because this will serve as the focal point of problem solving efforts. Step 2. Develop performance measures and collect data. The solution must be based on facts. Possible tools include check sheet, scatter diagram, histogram, rank chart, and control chart. Step 3. Analyze the problem. Possible tools include Pareto charts, cause and effect diagram. Step 4. Generate potential solutions. In this step, methods include brainstorming, interviewing, and surveying. Step 5. Choose a solution. Identify the criteria for choosing a solution. And in this step, you should refer to the goal established in step 1. Then, apply criteria to potential solutions and select the best one. Step 6, implement the solution, and you should keep everyone informed. Step 7, monitor the solution to see if it accomplishes the goal. If not, modify the solution or return to step 1. Possible tools include control chart and run chart. The plan, do, study, act cycle, also referred to as either the Stewart cycle or the Deming wheel, and is the conceptual basis for problem-solving activities. And there are 4 basic steps in the cycle. First one is plan. Begin by studying the current process and document that process. Then collect data on the process or problem. Next, analyze the data and develop a plan for improvement. In this step, specify measures for evaluating the plan. The second phase is do. Implement the plan on a small scale if possible. Document any changes made during this phase and collect data systematically for evaluation. The third phase in the cycle is study. Evaluate the data collection during the do phase. Check how closely the results match the original goals of the plan phase. The fourth phase is act. If the results are successful, standardize the new method and communicate the new method to all people associated with the process. And implement training for the new method, of course. But if the results are unsuccessful, revise the plan and repeat the process or end this project. The term Six Sigma has several meanings. Statistically, Six Sigma means having no more than 3.4 defects per million opportunities in any process or product or service. Conceptually, the term is much broader, referring to a program designed to reduce the occurrence of defects to achieve lower costs and improve the customer satisfaction. It is based on the application of certain tools and techniques to selected projects to achieve strategic business results. In the business world, Six Sigma programs have become a key way to improve quality, save time, cut costs, and improve customer satisfaction. Six Sigma programs can be employed in design, production, service, inventory management, and delivery. It's important for Six Sigma projects to be aligned with organization strategy. Note that there are management and technical components of Six Sigma programs. The management component involves providing strong leadership, defining performance metrics, selecting projects likely to achieve business results, and selecting and training appropriate people. The technical component involves improving process performance, reducing variation, utilizing statistical methods, and designing a structured improvement strategy, which involves definition, measurement, analysis, improvement, and control. For Six Sigma to succeed in any organization, top management must formulate and communicate the company's overall objectives and lead the program for a successful deployment. Other key players in Six Sigma programs are the program champions, which are the master black belts, the black belts, and the green belts. Champions identify and rank the potential projects and help select and evaluate candidates, manage program resources, and serve as advocates for the program. Master black belts have extensive training in statistics and the use of quality tools. They are teachers and mentors of black belts. Black belts are project team leaders and responsible for implementing process improvement projects. Green belts are members of project teams. Black belts play a pivotal role in the success of Six Sigma programs. They influence change, facilitate teamwork, provide leadership in applying tools and techniques, and convey knowledge and skills to green belts. Black belts candidates generally have a proven strength in either a technical discipline, such as engineering, or a business discipline. Candidates also must have strong people skills and be able to facilitate change, and they must be proficient in applying continuous improvement and statistical methods and tools. A black belt must understand the technical aspects of process improvement as well as the expected business results. Guiding principles of Six Sigma. Six Sigma is based on these guiding principles. First, reduction of variation is an important goal. Second, the methodology is data-driven. It requires valid measurements. Third, outputs are determined by inputs. Focus on modifying and/or controlling inputs to improve outputs. Fourth, only a critical few inputs have a significant impact on outputs, which called the Pareto effect. Problem-solving process of Six Sigma. Define, measure, analyze, improve, control is a formalized problem-solving process of Six Sigma. It's composed of 5 steps that can be applied to any process to improve its effectiveness. The steps are: first, define, set the context and objectives for improvement. Second, measure, determine the baseline performance and capability of the process. Third, analyze, use data and the tools to understand the cause and effect relationships of the process. Fourth, improve, develop the modifications that lead to a validated improvement in the process. Fifth, control, establish plans and procedures to ensure that improvements are sustained. Quality certifications. Many firms that do business internationally recognize the importance of quality certification. The International Organization for Standardization, shortly ISO, promotes worldwide standards for the improvement of quality, productivity, and operating efficiency through a series of standards and guidelines used by industrial and business organizations, regulatory agencies, governments, and trade organizations. The standards have important economic and social benefits. Not only are they tremendously important for designers, manufacturers, suppliers, service providers, and customers, but the standards make a tremendous contribution to society in general. They increase the levels of quality and reliability, productivity, and safety, while making products and services affordable. The standards help facilitate international trade, and they provide governments with a basis for health, safety, and environmental legislation. And they aid in transferring technology to developing countries. Two of the most well-known of these are ISO 9000 and ISO 14000. ISO 9000 pertains to quality management. It concerns what an organization does to ensure that its products or services conform to its customers' requirements. ISO 14000 concerns what an organization does to minimize harmful effects to the environment caused by its operations. Note that both ISO 9000 and ISO 14000 relate to an organization's processes rather than its products and services. And both stress continual improvement. Moreover, the standards are meant to be generic, no matter what the organization's business. If it wants to establish a quality management system or an environmental management system, the system must have the essential elements contained in ISO 9000 or in ISO 14000. The ISO 9000 standards are critical for companies doing business internationally, particularly in Europe. And they must go through a process that involves documenting quality procedures and on-site assessment. The process often takes 12 to 18 months. With certification comes registration in an ISO directory that companies seeking suppliers can refer to for a list of certified companies. They are generally given preference over unregistered companies. Also note that a key requirement for registration is that a company review, refine, and map functions such as process control, inspection, purchasing, training, packaging, and delivery. Similar to the Baltic Award, the review process involves considerable self-appraisal, resulting in problem identification and improvement. But unlike the Baltic Award, registered companies face an ongoing series of audits and they must be re-registered every 3 years. In addition to the obvious benefits of certification for companies that want to deal with the European Union, the ISO 9000 certification and registration process is particularly helpful for companies that don't currently have a quality management system. It provides guidelines for establishing the system and making it effective. Eight quality management principles form the basis of the latest version of ISO 9000. 1. A customer focus. 2. Leadership. 3. Involvement of people. 4. A process approach. 5. A system approach to management. 6. Continual improvement. 7. Use of factual approach to decision making. 8. Mutually beneficial supplier relationships. The standards for ISO 14000 certification, of course, bear upon three major areas. 1. Management systems. Systems development and integration of environmental responsibilities into business planning. 2. Operations. Consumption of natural resources and energy. 3. Environmental systems. Measuring, assessing, and managing emissions, effluents, and other waste streams. ISO 24700. ISO 24700 pertains to the quality and performance of office equipment that contains reused components. Also, ISO 24700 specifies product characteristics for use in an original equipment manufacturer's or authorized third party's declaration of conformity to demonstrate that a marketed product that contains reused components performs equivalent to new, meeting equivalent to new component specifications and performance criteria, and continues to meet all the safety and environmental criteria required by responsibly built products. It's relevant to marketed products whose manufacturing and recovery processes result in the reuse of components. Quality tools. There are a number of tools that an organization can use for problem solving and process improvement. This topic describes 8 of these tools. The tools aid in data collection and interpretation and to provide the basis for decision making. Note that the first 7 tools are often referred to as the 7 basic quality tools. Flowcharts. A flowchart is a visual representation of a process. As a problem-solving tool, a flowchart can help investigators in identifying possible points in a process where problems occur. The figure represents a simple flowchart. And note that the diamond shapes in the flowchart represent decision points in the process, and the rectangular shapes represent procedures. The arrows show the direction of flow of the steps in the process. Also, to construct a simple flowchart, begin by listing the steps in a process. Then, classify each step as either a procedure or a decision point. Try to not make the flowchart too detailed, or it may be overwhelming, but be careful not to omit any key steps. Check sheets. A check sheet is a simple tool frequently used for problem identification. Check sheets provide a format that enables users to record and organize data in a way that facilitates collection and analysis. This format might be one of simple check marks. Also, check sheets are designed on the basis of what the users are attempting to learn by collecting data. Many different formats can be used for a check sheet, and there are many different types of sheets. One frequently used form of check sheets deals with type of defect. The figure shows tallies that denote the type of defect and the time of day each occurred. Problems with missing labels tend to occur early in the day, and the smeared print tends to occur late in the day, whereas off-center labels are found throughout the day. Also, identifying types of defects and when they occur can help in pinpointing causes of the defects. Histograms. A histogram can be useful in getting a sense of the distribution of observed values. Among other things, one can see if the distribution is symmetrical and what the range of values is, and if there are any unusual values. The figure illustrates a histogram. Note the two peaks. This suggests the possibility of two distributions with different centers. Possible causes might be two workers or two suppliers with different quality. Pareto analysis. Pareto analysis is a technique for focusing attention on the most important problem areas. The Pareto concept is that relatively few factors generally account for a large percentage of the total cases. The cases may be complaints, for example, or defects, or problems. The idea here is to classify the cases according to degree of importance and focus on resolving the most important and leaving the less important. Often referred to as the 80-20 rule. The Pareto concept states that approximately 80% of the problems come from 20% of the items. For example, 80% of machine breakdowns come from 20% of the machines. Another example, 80% of the product defects come from 20% of the causes of defects. Scatter diagrams. A scatter diagram can be useful in deciding if there is a correlation between the values of two variables. A correlation may point to a cause of a problem. The figure you see shows an example of a scatter diagram. In this particular diagram, there is a positive relationship between the humidity and the number of errors per hour. High values of humidity correspond to high numbers of errors and vice versa. On the other hand, a negative relationship would mean that when values of one variable are low, values of the other variable are high, and vice versa. Note that the higher the correlation between the two variables, the less scatter in the points. The points will tend to line up. Conversely, if there were little or no relationship between two variables, the points would be completely scattered. Also, in the figure you see, the correlation between humidity and the errors seemed strong because the points appear to scatter along an imaginary line. Control charts. A control chart can be used to monitor a process to see if the process output is random. Also, it can help detect the presence of correctable causes of variation. The figure you see illustrates a control chart. Control charts also can indicate when a problem occurred and give insight into what caused the problem. Cause and effect diagrams. A cause and effect diagram offers a structured approach to the search for the possible causes of a problem. It's also known as a fishbone diagram because of its shape, or an Ishikawa diagram. Note that this tool helps to organize problem-solving efforts by identifying categories of factors that might be causing problems. Often, this tool is used after brainstorming sessions to organize the ideas generated. The figure you see illustrates one form of a cause and effect diagram. Some errors are more likely causes than others, depending on the nature of the errors. If the cause is still not obvious at this point, additional investigation into the root cause may be necessary, involving a more in-depth analysis. Often, more detailed information can be obtained by asking who, what, where, when, why, and how questions about factors that appear to be the most likely sources of problems. Run charts. A run chart can be used to track the values available over time. This can aid in identifying trends or other patterns that may be occurring. The figure you see provides an example of run chart showing a decreasing trend in accident frequency over time. Important advantages of run charts are ease of construction and the ease of interpretation. Methods for generating ideas. Some additional tools that are useful for problem solving or for process improvement are brainstorming and quality circles and benchmarking. Brainstorming. Brainstorming is a technique in which a group of people share thoughts and ideas on problems in a relaxed atmosphere that encourages unrestrained collective thinking. The goal is to generate a free flow of ideas on identifying problems and finding causes and finding solutions and ways to implement solutions. In successful brainstorming, criticism is absent. No single member is allowed to dominate sessions. And all ideas are welcomed, of course. Structured brainstorming is an approach to assure that everyone participates. Quality circles. One way companies have tapped employees for ideas concerning quality improvement is through quality circles. The circles comprise a number of workers who get together periodically to discuss ways of improving products and processes. Not only are quality circles a valuable source of worker input, they also can motivate workers if handled properly by demonstrating management interest in worker ideas, of course. Quality circles are usually less structured and more informal than teams involved in continuous improvement. But in some organizations, quality circles have evolved into continuous improvement teams. Perhaps a major distinction between quality circles and teams is the amount of authority given to the teams. Typically, quality circles have had very little authority to implement any but minor changes. Also, continuous improvement teams are sometimes given a great deal of authority. Consequently, continuous improvement teams have the added motivation generated by empowerment. Benchmarking. Benchmarking is an approach that can inject new energy into improvement efforts. Benchmarking can be defined as the process of measuring an organization's performance on a key customer requirement against the best in the industry or against the best in any industry. Its purpose is to establish a standard against which performance is judged and to identify a model for learning how to improve. Also, a benchmark demonstrates the degree to which customers of other organizations are satisfied. Once a benchmark has been identified, the goal is to meet or exceed that standard through improvements in appropriate processes. The benchmarking process. The benchmarking process usually involves these steps. First, identify a critical process that needs improvement. Second, identify an organization that excels in the process, preferably the best. Third, contact the benchmark organization, visit it, and study the benchmark activity. Fourth, analyze the data. Fifth, improve the critical process at your own organization.